Hi, my name is Bryce Summers, and today we are going to invert a matrix using the Summers Computer-Aided Mathematics program. So, here we have an example matrix that we would like to invert. We're going to be inverting it using the Gauss-Jordan Elimination model, which is essentially forward row reducing and then backward row reducing. The first thing we need to do is we need to augment the matrix with an identity matrix to the right of it. So first we want to capture the first data entries. So we go to the all button to select all of the data. Now that we have it, we want to augment it. So we click on the matrix to go to the matrix editing screen. Once we're here, we want to augment the matrix with a 3x3 identity matrix. We do that by adding adding 3 columns. Now we type in the ones to create the ones along the diagonal within the identity matrix. Click, type in 1, click here, type in 1. I'm now going to press tab, 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 just for fun. Now we type in 1. So we've now created the matrix that we were trying to create. So we press the done button. Now we're going to evaluate this. Now we're going to type a useful comment to describe to let our posterity know that we've augmented the matrix. So now we're going to perform forward row reducing using elementary row operations. So the first thing we need to do is we need to subtract 2 times row 0 from row 1. Like always, we want to first select the row that we wish to mutate, which is row 1. Now we're going to subtract 2 times row 0. So subtract 2 times row 0. Now we're going to evaluate this. We're going to scroll down to make sure we always see the last result. So now we're going to subtract 1 times row 0 from row 2. Like always, we're going to first click on the row that we wish to mutate. So row 2, we're going to subtract 1 times row 0. We could multiply it by 1, but this really wouldn't do much. So I'm going to press backspace. I'm going to press backspace again. Now we evaluate it. If I'm going to take this time to do some documenting. So row 1 goes to row 1 minus 2 times row 0. And row 2 goes to row 2 minus row 0. Now we're going to eliminate this 4. So an easy way to do this would be to make our numbers simpler. So we're going to divide this by -3. Row 1 divided by -3, then evaluate it. It becomes a 1. Now we're going to transform this into a 1. So row 2 divided by -4, and then evaluate. Now we're going to subtract row 1 from row 2. As always, we're going to click on the row that we wish to mutate. So row 2 minus row 1, evaluate. Now we need to back substitute. Well, not back substitute, but back reduce. So we're going to subtract row 2 from row 1 to get rid of this -3. So row 1, which is the one we want to mutate, subtract. Actually, we don't want to subtract. Let's undo that. We're going to add row 2. Evaluate. Notice the 0 here now. While we're at it, we might as well transform this back into a 1 because it'll be needed later. So we're going to multiply row 2 by -3. Row 2 times new scalar. Click here. Type in -3. Then we're going to evaluate it. Therefore, we have the last one. So now we're going to get rid of this one. So we're going to subtract row 2 from row 0. Row 0 is the one we wish to mutate, so we click on it first. Now we're going to subtract row 2. There we go. Row 0 subtracted by row 2. Now we're going to evaluate it. We're now going to subtract 2 times row 1 from row 0. So we click on row 0, which is the one we wish to mutate. Now we're going to subtract 2 times row 1. Now we're going to evaluate it. And we have this identity matrix over here. So now we can conclude that we're done. Let's write a celebratory comment. Done! Woo-hoo-hoo-hoo! I love it when we're done. But so how do we know if the voodoo magic that is Gauss-Jordan Elimination actually inverted the matrix? Well, first of all, we should extract the actual result matrix, and then we'll multiply by the original matrix, and we should get an identity matrix. So first, let's extract this matrix. So let's select all. Now we want to delete the first 3 columns. So we click here, and we're going to delete the first 3 columns. So we select this first column, and we press delete. We select this column, and we press delete. We select this column, and we press delete. Now we have the matrix we desired, so we're done. So we click on the done button up here. Now the result is in the operations pane. So now we're going to evaluate it. Let's call it answer. I sure hope that's how we spell answer. So now to check, we're going to multiply the answer matrix by the original matrix. So first, we select the answer matrix, select all. Now we're going to multiply. We don't actually have to click here. If we were to just multiply it by something without the multiplication operator, the program is smart enough to know to default to multiplication. So we're going to multiply it by the original matrix. So over here, we use the scroll bar and we go back up to the top, to the original matrix. Now we're going to select all, and now we're multiplying 2 matrices together. Let's scroll back down to the bottom. So to evaluate this result, we click on the evaluate button. And look at that. The answer is correct. The answer is correct. And there you have it. This has been a riveting example of how to invert a matrix using Gauss-Jordan Elimination, using the Summers Computer-Aided Mathematics program. Thank you very much for listening.